things that we talked about when we started this unit off were galaxies. So we talked about the fact that there are 3 types of galaxies. There are irregular galaxies. There are spiral galaxies. And there are elliptical galaxies. Irregular galaxies are the youngest galaxies. They look like, they don't really have any definite shape, okay? So they look kind of like a dust cloud. Spiral galaxies are medium-aged, okay? They have a central dense core, or central bulge is what it's called, and then arms that extend out from the central bulge. So the older stars that are more dense will be found within the central bulge, and then the younger stars are out on the arm. So, for example, our galaxy is the Milky Way galaxy. And in the Milky Way galaxy, our solar system is found out on one of the arms, okay? The last type that we talked about were elliptical galaxies, and they have the oldest stars. They are the most dense, and they have the most definite shape. So elliptical galaxies look spherical or sometimes oval or cigar-shaped, okay? Now, the next thing that we talked about in class was the life cycle of stars. Okay, and this was where y'all did that cut and paste activity with all the different types or parts of the life cycle with their descriptions. So, all stars start as a ball of dust and gas called the nebula. From the nebula, as they begin fusing hydrogen into helium, okay, that's fusion, they become a protostar, okay? So they start making energy here. The initial mass that protostar has, okay, so the initial mass is what determines the life cycle. So we know at that point whether a star is going to be a giant or a supergiant, and whether it's going to end as a black dwarf or as a neutron or a neutron star or a black hole. So after the protostar, then all stars go through a growing period called main sequence. Now, 90% of all stars are in the main sequence, okay? Our sun, which is the star called Sol, is in the main sequence, okay? In the main sequence, they continue nuclear fusion all the way through the main sequence. Now, we already know what they're going to become. So the less massive stars, like our sun, okay, the less massive stars like our sun are going to be giants. And giants will continue to fuse hydrogen into helium all the way up and continue nuclear fusion until carbon, okay? And then they begin losing their energy, at which time they, a planetary nebula occurs, which is where you start seeing this ring around the star. Okay, so you have the planetary nebula, and from that point, it shrinks down, it collapses in on itself to become a white dwarf. And then finally, so there's our white dwarf, and then finally a black dwarf, which no longer emits energy. Okay, so our sun will die as a black dwarf. Okay. And when we talk about our sun, since it's in main sequence and since it's going to follow this path, it's considered all around just an average star. Okay. The super massive stars, so the more massive stars, instead of becoming giants, they become supergiants. And so they continue to fuse hydrogen to helium and then continue through nuclear fusion all the way up to the heavy metals like iron. Once they start fusing those heavy metals, they get so dense that an explosion occurs, a major explosion, which creates a supernova. So a supernova is that major explosion. And those release a huge amount of energy. And there are some beautiful pictures. If you will just Google up supernova, you can see some awesome images of supernova. From that point, the biggest of the big, so these are going to be the most massive, have so much mass that when a supernova occurs, they collapse in on themselves to where no light escapes. The gravity is so great that no light escapes, and they create a black hole. Okay. Now the guys that are still supergiants and they still undergo a supernova, but they're just a little bit less massive than the most massive, they create a neutron star, which is the most massive, the most dense of any star that we know of. And they also emit radioactive waves. So neutron stars are also an option for the death of supergiants. Okay. So to look back at this, all stars are created as a nebula. Then once they begin fusion, they become protostars. All stars go through main sequence, but their initial mass determines whether they become giants or supergiants. Stars like our sun will become giants and then die as black dwarfs. Other stars that are more massive than our sun will become supergiants. They will all undergo a supernova. The largest of the large, the most massive, will create a black hole. And the ones that are just a little bit smaller, but still supergiants, will create neutron stars.